This is going to be the walkthrough for exercise 2. This is week 7, the online lecture, classes and objects. And in this lecture, we're going to take a look at the Hokey Pokey and sort of get an example of the power that object-oriented design and the use of classes and objects provides us when writing a program. To demonstrate this, we're actually going to revisit a program that we did in week 5. That's going to be the Hokey Pokey program. And if you need it, you can get it off of Blackboard. You can grab it from the exercise. I've put up a copy of the completed program, and I want you to go ahead and download it. If you don't have your own, we're not even going to open it up in Alice. What I want you to do is import it directly into NetBeans, and just watch how we're going to do this. We're going to import from an existing Alice project. We're going to go ahead and find our project, and I'm going to have to dig through my computer again, because of course NetBeans doesn't remember anything. So let me get through here. Oops. And into my 111 folder, my week 7, and my in-class exercises. And instead of the project name being Hokey Pokey, we're going to call this Hokey Pokey Inheritance. Now, make sure you change the project location to be wherever you'd like it to be stored. I'm going to go ahead and click Finish and let this import. As we've seen with classes, it's really nice because we have this model that lets us define all of our, all the information and actions that we want to use to represent something. And if we look at the tortoise, as we did a couple of weeks ago, we put all of the methods for the Hokey Pokey inside the tortoise, because if we run this, we're going to see that only our tortoise can do the Hokey Pokey. And that's okay. And you can hear my music, and you can see that only the tortoise is doing the Hokey Pokey. Neither the alien or the baby Yeti are able to do the Hokey Pokey. And that's because only the tortoise model contains the actions, the methods, to do the Hokey Pokey. Now, the one thing about classes is that, and again, we'll cover this in detail in CIT 130, but the classes can actually, the term is inheritance, but take advantage of another class. For example, we can have a class that generally represents animals, and then a class that more specifically represents a dog or a cat or a human, all of which are considered by science to be animals. In the case of Alice, remember that Alice breaks things down into flyers, swimmers, bipeds, and props. So our tortoise, our alien, and our baby Yeti are all bipeds, because they all stand on 2 legs. So we get to the tortoise gets to take advantage of everything that's in biped, plus everything that's in tortoise. If we look at baby Yeti, we see that baby Yeti also comes from a biped. And if we were to look at the alien, we would see that the alien also comes from a biped. What this tells us is that if we wanted to give, all of our objects, all of our classes, our blueprint for our alien, our blueprint for our tortoise, and our blueprint for our baby Yeti, to have the ability to do the Hokey Pokey, we could simply move those actions into the biped class. So I'm going to go into the tortoise, and I'm going to go ahead and I'm going to take all these methods, the Hokey Pokey verse, shake, turn around, and I'm just going to grab all of these. I'm going to cut them. I'm going to go into the biped, and I'm going to paste them. And now I actually have the ability to have all of my creatures do the Hokey Pokey. And if I go back to the scene, it's going to take a little work, but you saw an example. If I copy and paste this, if I just enter the same code that I have in the group of lines above me. I can make the alien hokey pokey. It's not voice, it's void. And I can do this again for my Baby Yeti. Now, what happens here is when the hokey pokey method is called, the first thing we do is go to the model for the tortoise. And we ask the model or the class, is there a method here? Does that method exist here? Does the hokey pokey method exist here? We don't see it here. But then what Java does is says, this little keyword extends means there is a relationship between tortoise and biped. What it means is tortoise is a more specific version of a biped. So that means that we can actually go into the biped class and say, does it exist? And as long as it's public, and it's there, it exists. And hey, look, here's hokey pokey. So there's sort of a chain involved here. Okay? So, and that's going to happen for each item. And let's go ahead and run this. And let's take a look at how it looks. Looks pretty good, right? They're all doing the hokey pokey so far. Now, notice one little thing. As this goes through, notice that the Yeti can't really put his arms up because of the way he's designed. Well, that's okay. One of the other nice features to using classes is that I can sort of override things if they don't work out for me the way I want. I'm going to close this. Okay, and since the Baby Yeti can't lift his arms the whole way up, right? You know, when you turn around, you put your arms up, you spin around, you put your arms back down. Well, he kind of goes out to here, you know? And in real life, if he's in a group of people and he does this, he's going to take a few people. And he puts his arms straight out, he's going to take a few people out. But that's okay. We can fix that. Because remember what I said. When we call the hokey pokey method, what we're doing is we're going and looking in Baby Yeti and we're saying, is there a hokey pokey method? No. Okay, then let's go to biped and look. So we go into biped and look. And there is a hokey pokey. So we do hokey pokey verse. And it says, okay, I'm going to look in Baby Yeti to see if there's a hokey pokey verse. And there is no hokey pokey verse. So then I'm going to go back to biped. Is there a hokey pokey verse? Yes. And eventually we get to the turnaround method. It's going to go back to the Baby Yeti and say, is there a turnaround method? No, there isn't. So it's going to go back to biped. One of the nice things is, if we don't like this, we can create our own. So I can just say public void turn around, and I just want the Baby Yeti to just spin, right? Because we don't want him to put his arms straight out. He's going to knock some people over. So we're just going to have him spin. I'm going to switch around here and look. And it's turn. We're going to have him go to the left. 1 revolution. We're going to make him do this 5 times. And like I said, we're just going to have them do it 5 times, so I'm just going to copy this statement and paste it in 4 more times. Now, we haven't talked about loops yet. We will soon. We could use a loop for this. For those of you who do have a little bit of programming experience, we could do a loop here. But since we don't have that option yet, because we don't know how to do that, we'll just repeat the statement 5 times. And now, if we watch this, we're going to have a bit of a change. All right, notice, still does everything the same as everybody else. However, when it comes to the turnaround method, Java's going to go look for it first in Baby Yeti. It's going to find one, and it's going to execute it instead of going into the biped. And this is one of those things that makes classes so very powerful. It allows us, I'm going to go ahead and close that. It allows us to adapt our classes without rewriting them. Notice we didn't rewrite the biped. Notice that we didn't have to put our all of our hokey pokey methods into each class in order to make it work. We put it in the biped model, and since the alien is just a more specific biped, the tortoise is just a more specific biped, and the Baby Yeti is just a more specific biped. We got access to that stuff. This is the idea behind reuse, and I've been talking to you all along that object-oriented languages permit reuse. This is something we spoke about the very first night that we talked about Java and its capabilities. Java permits reuse. This is one way that Java lets that happen. Again, not something we're getting onto a whole lot of details with this time around. I just want to make you aware that these features and functionality are available, that this stuff exists, because once you get beyond 1.11, you're going to be forced to, if you're using Java, you're really going to be forced to approach these from approach problems from an object-oriented perspective and understand how that works. And my goal here is just to sort of get your feet wet in that world. If you have any questions about this exercise, feel free to email me, bsimbeck@ccac.edu. Make sure you put in your subject line your course, CIT 111, in your section. Put in the subject line Week 7, Exercise 2 question. And that'll help it get to the top of my email list. Again, thank you for watching, and you may move on to the next exercise.